Greetings, everyone. This is Group 6, Team Ankit and Co. Our topic is disjoint set ADT and self-organizing list. A self-organizing list is an ADT which reorders itself where each element that is accessed moves closer to the front to improve average access time. A disjoint set ADT is a data structure which manages a multiple number of disjoint subsets. These subsets mean a disjoint subset means multiple two different disjoint subsets will have unique elements present in them that is not common amongst both, and the intersection of these two subsets will result in a null set. This will be at the agenda for our meeting. Moving on. A self-organizing list is a list where the recently accessed element moves closer to the front, which helps us in having a much more efficient time complexity while accessing the elements of the list. There are three major methods in implementing a self-organizing list. One is the first picture, where the node that is recently accessed moves to the front of the list, making it making it a constant operation while we access it the second time. The second method is where we have a count variable in the node itself along with the node pointer and the data. This count variable acts as an index where the element with the highest count value is in the front of the linked list and the element with the least count value is in the end of the linked list. Number 3 is a transpose method where the element that is accessed shifts itself with the previous element coming one step closer to the front of the list. These are the functions that we have used in implementing each of these methods. 1. Search, where the time complexity is linear. 2. Insert, where the time complexity is constant. And 3. Delete, where the time complexity is linear again. Some of the applications of self-organizing lists are caching systems, web browsers, network routing, and file systems. In these systems, using these will help us because these systems are basically built upon the principle of least recently used and most recently used. Moving on to Dinesh for disjoint set ADT.
Disjoint set ADT is also known as a union find data structure. It is a ADT that keeps track of the collection of disjoint sets. There are two functions that are used in disjoint set ADT. One is find, in which given an input number, we find the set in which the number belongs to. It uses recursion to find the parent of the set. Uh, the time complexity for this would be order of log n, and in the worst case, it is order of n. And the next function is union, in which we take two inputs x and y, and then we merge the sets to which x and y belongs to. And and the and the value it returns is a set that contains the union of x and y. Time complexity for this operation is again log n, and in the worst case, it is order of n. And the applications of disjoint set ADT include disjoint set forests, dynamic connectivity problem, image processing, and games. In the 6 phases of the software development lifecycle, the first step was analysis, in which our project manager Ankit and the business analyst Anuj Siddharth did some analysis on a project, and they gave us a initial design for which our developers, myself, Hari Sudarshan, developed a design for the disjoint set ADT, and then Mithun, Kenson, and Sharon made a prototype for the self-organizing list, and then we developed the code for both disjoint set and self-organizing list, and then our testers Santosh, Gautam Shiva, and Aditya S tested our code, and then they found out the boundary conditions and edge cases, and then we deployed the code on GitHub, and then the testers and developers maintain the code through GitHub. And now Sharon will share the code from GitHub. And now we will look at the working of self-organizing list using the count method. Initially, I will insert a few numbers into the list. this is our list 1, 2, 3, and 4. And now let's say if I search for the number 3, the count of 3 will increase to 1, and hence 3 will move to the front of the list. As you can see, 3 has been moved to the front. And now if I search for the number 1 twice, the count for 1 will become 2, and hence 1 will move to the front. As you can see, 1 has now moved to the front. So this is basically how the count method works. Moving on to the move to front method, I will first insert a few numbers to the list. And this is our list 4, 3, 2, and 1. And now let's say I search for the number 1. 1 will become the head of the linked list. As you can see, 1 has become the head. And now if I search for the number 3, 3 will now become the head of the list. As you can see, 3 has now become the head. So this is basically how the move to front method works. Moving on to the transpose method. So this is our list 1, 2, 3, and 4. And now let's say we search for the number 4, it will get swapped with the number 3, since 3 is the previous node of 4. As you can see, 4 has been switched with 3. And now if I search for the number 4 again, it will swap with the number 2. As you can see, 4 has been swapped with 2. This is basically how the transpose method works. In all these three methods, our end goal is to make the search operation order of 1. And subsequent searches will make the number move closer to the head, and hence the search operation will become order of 1. Moving on to the disjoint set ADT. Here, here initially we have to make a set containing a single number. So first we will make a set which has the number 1, and then we'll make another set with the number 2. And now we have two sets which has one has number 1 and the other has the number 2. And now if I make the union of these two sets, the sets have now been merged. So now we have a set which contains the numbers 1 and 2. Now if I do find set of 2, we get parent of 2 is 1, which means 1 and 2 both belong to the same set, and 1 is the parent of 2. And now let's create another set 3 and 4. And if I make a union of 3 and 4, 3 and 4 have now become the same set. And if I find set of 4, it will show parent of 4 is 3, which means 3 and 4 is the same set. And now if I make the union of the two sets 1, 2, and 3, 4, we'll get a bigger set containing all the 4 numbers. So let's say let's union the sets 1 and 4. And if I find set of 4, it will show parent of 4 is 1, which means that 1, 2, 3, and 4 have now merged into a single set, and 1 is the parent of all the 3 numbers. So this is basically how the disjoint set ADT works.